Let's now discuss about the distribution of charges on a conductor and the action of points. For this, let's consider two conducting spheres A and B. So these are the two conducting spheres A and B having a radii R1 and R2 which has been connected to each other by a conducting wire. Let R1 be greater than R2. Now a charge is given to the system which has been distributed. The charges are Q1 and Q2 on the surface of the spheres A and B. Let sigma 1 and sigma 2 be the charge densities on the sphere A and B. So the potential at A will be V1 equal to Q1 divided by 4 pi epsilon naught into R1, whereas the potential at B will be V2, that is equal to Q2 divided by 4 pi epsilon naught into R2. Since they are connected by a wire, their potentials are equal. Therefore, we can simply mention V1 is equal to V2. By substituting the value for V1 and V2, it will be Q1 divided by 4 pi epsilon naught R1, that is equal to Q2 divided by 4 pi epsilon naught into R2. On cancelling the similar terms, we will be getting sigma 1 into R1, that is equal to sigma 2 into R2. From the above equation, it is seen that the radius, so this one is the radius for the sphere A and this one is the radius for sphere B. So smaller the radius, larger is the charge density. So also from the equation which we have obtained over here, we can conclude sigma r is a constant. Apart from this, in case of a conductor which has been shaped in the distribution, you can see the non-uniformity over here. The charges accumulate to a maximum at a pointed end where the curve is maximum or the radius is minimum. So you can see the accumulation of charges. It is found experimentally that a charged conductor with sharp points on its surface loses its charge rapidly. Having a comparison in both the cases, you can see the minimal number of charges over here, whereas in terms of the charges that has been accumulated in the pointed area. The reason is that the air molecules which come in contact with the sharp points, that is over here, becomes ionized. And also the positive ions are repelled and the negative ions are attracted by the sharp points, and now the charge in them is therefore reduced. So this is all about emphasizing the action of points. Thus the leakage of the electric charges from the sharp points on the charged conductor is known as action of points, or else we can say this as corona discharge. This principle is made use of in the electrostatic machines for collecting charges and in some kind of lightning arresters, that is conductors.